Okay, this is a unit conversion example. It's got lots of elements to it that would be good for an exam. All right, so the idea here is that we know that there are 190 calories in a certain mass of peanut butter, 33 grams of peanut butter. We're going to eventually want to know how many calories are in the jar of peanut butter. So we're modeling the peanut butter jar with a cylinder. We know the formula for a cylinder. Okay, where R is the radius and H is the height. And we also know the specific gravity of peanut butter is 1.2. Okay, so let's get started. The first one, part A, if we throw the jar of peanut butter into a swimming pool, does the jar float? Okay, so remember what specific gravity is. Specific gravity is the density of an object relative to water. Okay, and so peanut butter, since that number is bigger than 1.2, peanut butter is more dense than water, so that means the jar of peanut butter would sink. Okay, you could probably have guessed that. Okay, but that's mathematically why it sinks. Okay, next, how many total calories are in the cylindrically shaped jar that has a height of 6 inches and a diameter of 3.5 inches? Okay, so I've already written out the given. We're given the radius. Actually, we were given the diameter, so I divided that by 2, and I got 1.75 inches for the radius. We know the height is 6. We know 190 calories in 33 grams of peanut butter. We know the specific gravity is 1.2, and we know, because we could look it up, I would have to give you this on an exam, but we know the density of water is 1,000 kilograms per cubic meter. Okay, so here's what I'm thinking. I'm thinking that density is given in a metric system. All right, we also have grams given, and grams is in metric. Let's head towards metric in this example. We could have gone towards English, but I think there's fewer conversions. You're going to have to get everything into a consistent set of units. I think there's fewer conversions if you go towards metric. All right, so that means we need radius in the metric system. So we start with 1.75 inches. Okay, then we know that in 1 inch, there's 2.54 centimeters. And we know that there are 100 centimeters in 1 meter. So we now have R in meters. Okay, so notice these cancel and we're left with just meters. Okay, we can do the same thing for H. 6 inches, 2.54 centimeters in an inch, and 100 centimeters in 1 meter. Rearrange these where all these cancel, and once again we're left with meters. Okay, so that lets us calculate the volume. We just simply plug in. We know what R is, we square it. We know what H is, we square it, and we get a number for the volume. So I've calculated that already. I get the volume to be 9.4597 times 10 to the minus 4th cubic meters. Now why cubic? Well, because R is in meters, okay, and then we square it. So there's square meters, and then H is in meters. So square meters times another meters gives me cubic meters, right? Which is what we were expecting. Okay, so next we need to relate grams. We have grams to calories. All right, so somehow we got to make the connection between volume and mass, and so that's done with the density. All right, so you were given this specific gravity. So specific gravity is the ratio of the density of peanut butter to the density of water. Okay, so we know that's 1.2. All right, so that would mean the density of peanut butter is 1.2 times the density of water. So that would be 1,200 kilograms per cubic meter, right? So we know that number as well, okay? So at this point, we can start doing the dimensional analysis. I think the way I would do that is start with the 190. Okay, so we know that we have 190 calories in 33 grams. Okay, so how did I know to write that? Well, I've done a lot of these problems, so this is a ratio. We have 190 calories in 33 grams. I write that down. Okay, then I know that I have 1,000 grams in 1 kilogram. Okay, and so at this point, I'm looking at canceling the kilograms, and I look through my list of things that I have. I see kilograms here, and so I multiply by 1,200 kilograms per cubic meter. All right, and so far everything's looking good. The grams cancel, the kilograms cancel. I now need to multiply by, I need to get rid of this meters cubed. I need to multiply by the volume. Okay, so the volume I know is 9.4597 times 10 to the minus fourth meters cubed. All right. So what I'm left with is the total calories. Okay, I call that TC. And I can just do that multiplication, and what I get for the answer is 6,5, if I keep all the precision in there, 6,535.8 calories. Okay, so I go back and I look at significant digits, and we were really carrying this probably to about 2 or 3 significant digits. Remember, I'm not super worried about that, so let's just call this 6,500 calories as the total calorie count in the jar of peanut butter. Okay, so that hopefully helps you work through units. There's all kinds of levels of problems I could give on the exam. I could just simply ask you to convert between 2 specific units, but as engineers, we really need to learn how to apply dimensional analysis when we plug into formulas. So we had to plug into a volume formula here. And really, if we just keep track of the units as we go, figuring out which direction we're trying to move everything into, in this case, we're moving everything to metric. Okay, if we do that and are careful with our work, we end up